Okay, so for today, we're solving by substitution. It's called substitution because you are going to be what? Wow, we're not going to be substitution. We're going to be substituting. All right, here we go. So what does that mean? I need everybody to look up here and highlight something for me. All right, it says that, here's the key, y is equal to what? Y equals, look, please don't make this hard. I mean, it's really, really simple. All right. I ask you, what does y equal? See this y right here. What does that y equal? So I substitute equals for equals. What does y equal? All I do is I replace this y with negative 3x. That's it. Everybody good with that? Now I need to solve this. Move the 6x over. Negative 9x equals negative 9. And so x equals what? X equals 1. Come on, Leah, what? What? Yes. X equals 1. Do we agree with that? Now, I have x. Your objective is to find x and y. So now I'm going to replace, or I'm going to substitute in 4x what? 1. All right. Y equals negative 3 times 1. What's negative 3 times 1? Y equals negative 3. So you're trying to find the point of intersection. So to find the point of intersection, it is x and then y. 1, comma, negative 3. 1, comma, negative 3. Now, if you have your handy-dandy calculator available, we'll just, because it's so easy, we're going to check it with our calculator. All right, type in under y1, negative 3x. Type in under y2, 6x minus 9. And because you did it 21 times yesterday, I'm sure it's just a click of a button here. All right. And we should be able to confirm that that's the point of intersection. Who has confirmed that? Thank you. All right. So 1, negative 3. Do you agree? 1, negative 3 is the solution. Say that again. You type in negative 3x for y1 and 6x minus 9 for y2. Then you graph it. Now, Palmer, you weren't here yesterday. All right, so you don't know how to use the calculator. That's why you're going to go home tonight and watch the video, and it'll explain exactly how to do it.
I figured out how to do it. You put, I think like this, but when you check it,
Second calc, second trace button,
right.
Then the intersection is 5, then hit enter, enter, enter. Okay, now, again, all right, in the interest of time, for those of you guys who don't know how to use your calculator, I don't understand. All right, you had 21 yesterday. 21 problems to do. Now, for question number 3. All right, once again, what does y equal?
Negative 2x.
Y equals negative 2x minus 9. So once I establish what y equals, I just replace it. That y value is negative 2x minus 9 equals 2x minus 1. Now I'm going to add 2x and add 1. 4x equals -8. So x is equal to what? So I know x equals -2. So now that I know x equals -2, I come right up here and I plug -2 in. Does it matter if I choose the top function or the bottom function? Does it matter what one I use? No, it doesn't matter. You get the same answer. So I'm going to plug in -2 for x. So y equals -2 times -2 minus 9. Y equals 4 minus 9. Y equals -5. So my answer is -2, -5. Is that right, Peter? All right, let's see how I'm doing. All right, look at number 5. A little bit harder now. What does y equal? So wherever I see a y, I need to put 6x plus 4. So 12x minus 2, parentheses, 6x plus 4 plus 8 equals 0. Does everybody agree with that? See that y? I just put in 6x plus 4. That's it. Now I'm going to distribute 12x minus 12x minus 8 plus 8 equals 0. Now we have all kinds of problems here. What happens to 12x minus 12x? Cancels out. What's -8 plus 8? Right, so it's telling you that 0 equals 0. All right, now that means it's a special case. It's a special case. Tell me what it is. Yeah, there's an infinite number of solutions. The reason why we say there's an infinite number of solutions is because it is the what? It is the same line. All right, if I were to graph the first one, there's what the line would look like. If I were to graph the second one, it would be right on top of it. So it's the same line. So we say there is an infinite number of solutions. There's an infinite number of solutions because it is the same line. So anytime all the variables cancel out and the numbers cancel out, it's an infinite number of solutions. All right, there's another special case we'll get to when we get there. All right, let's check out number 7 now. All right, here we go. What does y equal? Y equals 3x plus 2. So I'm going to plug y 3x plus 2. Palmer, what's the matter? What, Palmer? What? Palmer, you need to be strong enough to ask me questions, bud. Come on, what? Don't interrupt someone else. What didn't you understand, Palmer? Come on. No. -2 times +6 is -12. And -2 times +8 is -8. All right, let's try number 7 now. So I'm going to replace y. Now, the big mistake people make is they don't put parentheses in. So 3x minus parentheses 3x plus 2 equals 10. Distribute the negative. 3x minus 3x minus 2 equals 10. Now, what's true about 3x minus 3x? It cancels. So now it says that negative 2 equals 10. Is that a true statement? No. So we say it is no solution. This is the other special case. All right. This is a special case. If it has no solution, how did we have no solution yesterday? They were parallel lines. Thank you very much. Parallel lines. All right, these are parallel lines. If it has no solution, that automatically means they were parallel lines. All right, anybody have any questions with that? All right, let's carry on. Number 9. Again, I always used to like to highlight what something is equal to. What does y equal? So I'm going to dump that 2x minus 3 in for that y right there. So here we go. 2x minus 3 equals negative 2x plus 9. All right, now you should be able to move things pretty quickly now. If I add 2x, I'm going to get what? 4x. If I add 3, I'm going to get what? 12. Everybody should be able to do that. And so what is x, obviously? X is 3. Once you've established that x is 3, you come back up here and you plug 3 in. Yes. Y equals 2 times 3 minus 3. Y equals 3. That's not my answer. 3, 3. Your answer is, where do they intersect? The intersection is 3, 3. All right, if I were to graph that, I would end up with the point of intersection at 3, 3. Is everybody good with this? All right, here we go. All right, I'm going to pause the video. All right, I want everybody to. Okay, come on now. Again, I just don't think it's that difficult. It's a substitution. All right, what does y equal?
-13.
No. What does y equal?
6 minus x.
6x minus 6. Y is equal to 6x minus 6. So I'm going to put that in for this y right here. Negative 3x minus 3 parentheses 6x minus 6 equals negative 24. Anybody have a problem with that substitution? Anybody have any trouble with that substitution? Now I distribute the negative 3. Distributing the negative 3. Negative 3x minus 18x plus 18 equals negative 24. Anybody got a problem with that? Negative 3 and negative 18 is what? Negative 21x plus 18 equals negative 24. Subtracting 18, negative 21x equals, so x was 2. If you got that, you know how to do the substitution process now. Now, of course, we're not done. We got to plug 2 back in up here. So y equals 6 times 2 minus 6. So y is equal to 6. So my answer is what? 2, 6. Come on, it's not that hard. Not that hard. Anybody have any problems? All right, let's check out 13. All right, now this time they're telling you what x equals. All right, so let me pause it for a second. All right. Substituting in x equals what? So this x becomes 2y plus 10. Distributing. Uh-oh. What happens to the 6y's? So now, technically, you have 30 equals 30. So I always tell kids, if it's a true statement, that means there's an infinite number of solutions. Infinite number of solutions. And under infinite number of solutions, I want you to tell me that it is the what? It is the same line. All right, it is the same line. That's why there's an infinite number of solutions. If I would graph this one, then I would graph this one. How many times do they intersect? Infinite number of times. All right, yes, ma'am. That's exactly the correct answer. 6y minus 6y is 0y. I just didn't subtract 30 from both sides like you did. So now I would have 0y equals 0. Okay. All right, let's check out a fraction now. All right, everybody take a look at 15. What does x equal?
-4 reduce y plus 1.
Okay, so let's plug it in. 3 parentheses. Now, when you distribute the 3, what do we get? Say it. -4y plus 3 plus 4y equals 17. What happens to the y's? So does 3 equal 17? No, so that one's nice. No solution. Because it's no solution, that means they are what? Parallel lines. Thank you.
Why was the 17 not be negative?
Yeah, it's negative. No solution, parallel lines. Anybody got a question with that? All right, here we go. Well, we could, but it's already solved, but I just wrote it backwards. What does x equal?
Oh, just that.
Yeah, I just wrote it backwards to try to confuse you. X equals y minus 18. So we're going to come up here and see this x right here, and we're going to put y minus 18. So 7, open parentheses, y minus 18 minus y plus 15 must equal 0. Distribute, what do we get?
126.
You have a problem with that? Now, of course, we're just combining terms here. $126 plus 15 is what? Do we agree with that? Is that right? Now we solve. 6y equals 111. So y is equal to 111 divided by 6. And that doesn't go evenly, so we just have to reduce the fraction. We're going to reduce by 3, right? And that will be 37 over 2. Say it again. I don't care if you write 18.5, but generally write as fractions. If you wrote 18.5, is it the same thing? Yeah, it's the same thing. All right. So now, once you've established what y is, you knew that x was equal to y minus 18. So now x is equal to 37 halves minus 18. So my answer would be considered 1/2, comma, 37 halves. That's it. Yes.
How do you know which one goes first? Like in the, not like in the, like for the final product.
X comes before y. They're alphabetical order. All right, number 19. Yes, here we go. Now, I just showed you here, does it matter where you're at? X now is equal to what?
Oh.
So now I'm just plugging 6y. You have to observe. All right. And so now 8 parentheses 6y minus 16 plus y equals 19. Anybody else get 49y equals 147? So I got y equals 3. Anybody else agree with that?
Yes.
So if y equals 3, I'm plugging it in.
Mm.
2,3. Okay, now on the back. Listen, I really want you to know if you got it right. All right, tomorrow I'm going to show you how you can use your calculator nicely to solve all these on the calculator. All right, but for now, I just want you to practice doing the substitution method. All right, so check your answers. All right, I'm still going to collect it. I'm still going to check your work. It doesn't matter to me if you put the answers down. If you just put the answers down, it's not going to count. All right. And again, I need you doing your work. All right. I need you doing your work. All right. Anybody have any questions with that? All right. The answers are there. So please double check.